We have the first problem on the sheet, and I'm using qualified and unqualified as opposed to overqualified and not overly qualified, just a little easier to abbreviate these characteristics. So we're trying to understand the probability of a random selection of 12 people from a large group coming up with exactly 4 people who are overqualified, or who are qualified, let's say. So a person's either going to be qualified or unqualified. Now we're given that 40% of the people are qualified. Now I haven't put that down here, but that's part of the problem. Okay, so one way, we imagine filling 12 slots with qualified and unqualified individuals in such a way that 4 of them are qualified. So we have, in this case, the qualified individuals are here, 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 and here. They're chosen first, and then fourth, and then what's this, 8th, 9th, and unqualified people appear in the other slots. The remaining 8 are unqualified. Okay, so the probability of getting this specific result, first person's qualified, second unqualified, third unqualified, fourth qualified, etc., is what? Well, the probability of the first person being qualified, 40% of the people are considered to be qualified, which means 60% will be unqualified. The probability of the first person being qualified is therefore 0.4. Probability of the second person being unqualified is 0.6, 60%. Probability of the third person being unqualified is 60%, etc. So in this case, the probability is just going to be, the probability of getting this specific result is just going to be the product of the probabilities. The situation here is, it's a large corporation. Every person, or every choice, is not dependent on the choice you had before. It's be unlike a deck of cards, say, where if you have something that happens in the first will affect the probability of what happens in the second. We consider the corporation or the whatever it is to be large enough that these probabilities are going to be independent of how many people have already been chosen, at least among the 12. Okay, so we have independent probabilities. It follows then that the probability is the product of the individual probabilities. Probability of this outcome on 12 choices, 12 choices, is the product of these probabilities, and that product, we have 0.4 occurring 4 times because we have 4 qualified people, and 0.6 occurring 8 times because we have 8 unqualified people. Now, this is only one way that these people could have been chosen. We could have the qualified and unqualified in different positions among these 12, and from what we've seen earlier, we understand that there are C of 12 ways to choose the 4 positions in which we put the qualified people. So there are this many ways to fill the 12 slots with 4 qualified and 8 unqualified. So probability 4 qualified, 8 unqualified is going to be C of 12 ways to fill the slots times the 0.4 to the 4th times 0.6 to the 8th probability of any one of those C of 12 ways. Now this is similar to the formula C of NR equals P to the R times Q to the N minus R. P in this case would be the 0.4 probability of a qualified person, and Q would be the 0.6 probability of an unqualified person.